Alright, section 10.3 is talking about, so you have a circle and a measure of arc. We've talked a lot about that. So if I said the measure of this, yeah. 11. Have I been doing 10?
Yeah.
Oh, sorry.
You said it.
Oh, we're in chapter 11.
You said it.
Okay, I will say many things again. It's okay. 11.3, if that's 80 degrees right there, what's the measure of the arc? We'll call it AB. It's 80 degrees. The measure is 80 degrees. Now, if you wanted to, let's say this was a fence. You had a circular fence in your yard, and the dog tore down this portion of the fence or whatever. If you were to go into Menards, you couldn't ask for 80 degrees of fence, right? Obviously. Okay, but that's important that you know that because you have to know the difference. The measure of this is 80 degrees of the 360 total degrees. That's important. But the length of this depends on the radius. That's going to change everything. Here's the nice little formula. So we're going to make the radius 11 feet. And then we're going to use the formula for arc length, not measure. We already know the measure. The length is equal to 2 pi r, which is what? What is 2 pi r? What's the formula from?
Oh, surface
Perimeter, circumference, perimeter. We used it in surface area, but this is the circumference of the circle times the measure of the arc over 360. So the measure is incorporated, it's just not your final answer anymore. So get your calculators out and do this one with me. So in our example here, 2 pi 11 multiplied by 80 over 360. You'll want to start, probably, doesn't matter, but you may want to start with 80 divided by 360 first.
40.
And then multiply that by 11, by 3.14, and by 2. Well, I can't too much, Lauren, because then I wrote too wide. So I can't, I'll cut it all off. Is that big enough?
Yeah.
Okay. Mm-hmm. So what's our length of that fence then? What do we end up by?
In terms of pi or?
No, let's do in terms of feet. So just in terms of decimal. I guess you could do it in terms of pi and feet, but let's just do it in terms of, without terms of pi, just decimals. So for sake of time, I'm just doing it myself. You're going to have to trust me or you're going to want to try it and silently agree, hopefully. But the measure is 15.35, 15.4, something like that. You may be off a little bit, determining what you used, depending on what you used for pi. 15.35 is labeled with what?
Feet.
Why feet?
Because that's what the measurement was of the radius.
Okay, perfect. That's important to keep in mind because now we're going to go up to the next dimension. So this is circumference. What if I wanted to know how much of the pizza I ate? All right, so I'm going to do a sector of a circle, which is actually area. So sector is a area question, but it's not the entire area because we already know that. A sector of a circle says chop out this portion. So you want to know how much of the pizza you ate. So let's say that it's 10 inches, it's a very large size pizza.
Wait, the radius is 10 inches?
Yeah.
This is a 20-inch pizza?
It is. Go big or go home, that's what I heard. All right. So if I have a 100 degree.
Not that big a pizza.
That's a pretty big pizza.
No, it's not.
So we end up with a formula
12 inches.
of this.
Yeah.
I'm going to keep going. You guys have your conversation when you're ready. Join me. Area equals pi r squared.
Okay, guys.
100 degrees. I don't care. I'm going. You guys join me when you want, or you can watch the video later.
Can they hear us?
What do you think, my dear?
Oh,
Okay, here we go. Pi r squared equals measure of degrees over 360. Again, it needs to be used. The 100 degrees is important. important. It tells you about how much of the 360 you're using. But more information is needed if you're going to find the area. And in this case, it's using pi r squared. So you take the portion of 360 multiplied by the area of the entire circle. So pi times 10 squared, 100 over 360. The formula themselves, that formula is not something that I expect to be completely untouchable. Like some formulas are just ridiculous, you just use them. Like the surface area volume formulas, they're long, you just plug them in and you use them. I want you to understand that formula, because this formula, I think, makes a lot of sense tied into what you just learned. Super lots of sense. Well then, good things are happening.
So wouldn't it just be 360? Or
No, because you're dividing here, so it'd be,
3.6.
and then you multiply by 100 squared,
Oh, I forgot the pi.
or 10 squared, which is 100. And then again, labels are huge. This is inches squared because I'm dealing with area. The third and final thing I have for you today
It's nothing.
is area of a segment, which is kind of interesting. So a segment obviously is going to have a different definition here because a segment doesn't have an area. But an area of a segment of a circle looks like this. So you're going to have, again, another portion of the circle cut out. But the segment is just the portion that's here. That's what's a segment. So you see it does have area. It does have 2 dimensions. We're going to go ahead and say this is 60 degrees in here. We'll label the radius as 12. So the formula is directly related to the sector formula. You're going to find the area of the whole sector and just subtract out the triangle. So the formula equals sector minus the triangle, which obviously we have formulas for, but I want you to get the big picture. The triangle I'm talking about is the one that's created by the segment. So then the sector formula, this is a repeat from above, pi r squared times the measure over 360 minus the triangle formula, 1/2 base times height. So you're going to actually find the sector and then you're going to subtract out the triangle. Problem is, this triangle doesn't have a base and a height, so here comes your apothegm again, potentially. I mean, it's trig. It's not the whole 1/2 ASN because it's a triangle, but you're going to have to use some of your knowledge from that section.
Well, since you made it 60 degrees,
I know. Yeah, I made it nice for us. So pi r squared over 60, or times 60 over 360. Are we good with that part?
Yep.
Okay. So that's the measure of our arc, which is equal to the measure of the central angle, minus 1/2. What's the base length of our triangle? Do you agree they're all 60, 60, 60, so it's 12, 12, and 12? All right, so times 12. The question is, what's our height?
How do we know they're all 60, 60, 60?
If it's a 60-degree angle,
Oh, well, yeah.
and we know this is a radius, I mean, you'd have to know more. One 60-degree angle is not enough,
Yeah.
not enough. But what do you know about the radius here and then here again?
He said 12, I said 5.
It's 12.
Right, so then now if that's enough information. If it's isosceles with 60 degrees,
So
then it's
we're bringing back the
equilateral.
theorems, like,
Oh yeah, it's never left. Just temporarily, I guess. But anyway, you can draw your little triangle. Let's put it out here. Work with the 12, 12, 12 triangle, which mine's not looking so great.
Everybody has those days.
Oh goodness. Everybody has those days in May. Okay, 12. 12. Here's your height. This ends up being 6 and 6. Careful, you're on candid camera. We're videotaping. You're welcome to come in. Just say something really wise if you're going to.
I can't. I don't have anything wise.
You're out, huh? Alright.
Just one of your
Okay,
videos.
so cute.
So, here we go.
We're on camera today?
Will you talk about
Yeah.
videos, Pat?
That's
How
what
about we focus
Six.
on the notes? Sophie?
Let's get done.
No, I'm
We
interested in yours.
six.
How about
I'm gonna keep
no?
going. You listen. 6
No.
After?
is
No.
my half of the base. 90 degrees because the height does that. 12 is the hypotenuse. How can I find this measure?
Tangent of something, something, something.
Sure. What's easier, Derek? What's easier, Derek? Yes. That wasn't what I wanted.
We love
doing
that.
that.
No, we're not
369.
doing that. We're
We're
not
not.
doing that.
Wait. What? We're doing 369?
Miss Laura, can you slow down? It's like a little bit.
Sweet.
Yeah, I can't keep up.
You guys,
Homer, why?
a 60-degree angle cut in half at the top for the height to drop down means it's 30. So now I'm dealing with a 30, 60, 90 triangle.
Oh.
For sure, Pythagorean's theorem. That's okay.
Yes.
30, 60, 90. Super easy if you have your short side, which we do. It's a 6 side. The short side 6.
Oh, we can use like 11 to 3.
Yep. So 6 squared to 3 is what the answer to that long side is. Yes.
Since we're solving for the area of the triangle, could we just multiply the height of it by 6?
So say that again. I didn't follow what you were saying.
Since it's just we're solving for the area, could we just multiply 6 times the square root of 3 multiplied by 6 instead of 12?
Yeah, we
Oh,
just
yeah,
do that.
for
That'd be
sure.
easy.
Yeah, and just drop the half.
Yeah.
Yeah. Yep. All right. So then you end up with either a decimal, which is fine because you could do 12 squared equals 6 squared plus x squared, or you can do 30, 60, 90 rules. And then from here, you'd solve it. So either get your calculators out and do that, or just know how to do that. Know that you need to multiply each product separately and subtract at the end. I don't have the final answer, I don't think, in front of me.
13.04 inches squared.
13 point
04.
is the final. Okay. And inches squared because,
It's area.
good. Okay, so I'm going to turn off the video. I'm going to hand out your review.